Hi folks. Okay, here's video physics, my 10-minute YouTube timer. Okay, so Hurricane Sandy gave us a day off of class. I'm going to try to present everything that you need to know on video. Luckily, our big lab activity was supposed to be the second week of Module 5, so that'll be good. We won't miss anything really important. So Module 5 starts off talking about Newton's laws. First of Newton's laws, what would that be? Hopefully you can answer. Pause if you need to think about it. Okay, so an object in motion remains in motion. An object at rest remains at rest unless it's acted upon by an outside force. That's the law of inertia. That's another thing that it's called. What this talks about is that matter doesn't have a particularly favorite state or condition. Matter doesn't prefer to be at rest as opposed to moving. It only is at rest because no forces have caused it to become in motion. Matter is only in motion unless a force is acted upon it to bring it back to rest. So neither is a preferred condition of matter. Some things that make us think that matter prefers rest over motion, which of course isn't true, but what makes us think that is there's so many forces here on Earth that cause matter to come to rest. There's gravity, there's air resistance, and there's friction. But in the absence of those things, matter in motion will continue in motion unless acted upon by a force. Matter at rest will continue to stay at rest until acted upon by a force. So friction. Friction is what we're going to really look at next week heavily. Friction is a force that exists between two surfaces that are in contact. Friction always opposes motion. I know that we do a lab sometime called how much work does friction do? But I'm going to tell you friction doesn't actually do any work. It only opposes motion. The frictional force is very interesting, and we'll look at it in more detail next week. But the frictional force can actually change. Say a car is on a downhill slope. It isn't going downhill because there's enough frictional force to continue to keep it at rest. If there were no friction, of course, everything would roll downhill. But friction will oppose only to the extent that it keeps something in place. So if somebody comes up behind a parked car that's on an incline and start to push on the back end of the car to try to get it to go downhill, the force of friction will actually increase as the force on the car to go downhill increases. So friction will continue to increase to continue to oppose motion until there comes a point when enough force is being applied to the thing that it will actually start to go downhill. You can overcome the frictional force and cause something to start to move. But anyhow, the frictional force between any two surfaces is unique to the two surfaces, and we'll look at multiple surfaces next week. Frictional force between my two hands has its own unique characteristics. Frictional force between my finger and a blackboard, which I know you don't want to hear, has its own unique strength, I guess you could say. And there are several factors that actually cause the strength of the frictional force between things. One is adhesion, which is the electromagnetic interactions between any two kinds of matter. You know that all matter has the valence electrons. Those electrons are negatively charged. They'll have attractions to any positive nuclei that come near. Of course, there's, many atoms in my finger. They all have positive nuclei. So there's an attraction between two touching surfaces because their subatomic particles will have negative charge, positive charge. They'll come near each other. Sorry, you can hear my kid. Hush, guys. Adhesive forces, electromagnetic attractions between surfaces. Also, roughness of a surface, little imperfections. Even the smoothest of surfaces on the atomic or molecular level have little bumps and grooves. So even this very flat looking chalkboard does in fact have little bumps and grooves, and as things move past another surface, those little bumps and grooves, collide, get caught, cause little stoppages, and that's another cause of friction. Friction is one of the major reasons that matter seems to prefer rest, but that's not actually the case. Matter does not have a preferred condition or state. It doesn't prefer rest over motion. Make sure, I have a note here to read to you, make sure that when you talk about a force is a vector quantity. So if, say I'm applying a force to one of these surfaces in this direction, the frictional force would be going in the opposite direction. So when you need to report an answer, you could say something like, the force is in the opposite direction of friction, but you do need to give a direction because forces are a vector quantity. Time, doing okay. All right, second of Newton's laws. Most easily expressed by an equation. See if you can think of what the second of Newton's laws is. Okay, so the second one is the sum. This Greek symbol here means sum to us of the forces is equal to mass times acceleration. That's the second of Newton's laws. F equals ma, sum of the forces is equal to mass times acceleration. You've probably used that in math class lots of times, but that's Newton's second law. And what that means is that you have to account for every force acting upon a body to figure out what force is on it, or if you know the forces, then to figure out its acceleration, you have to know mass. So when you do any of the problems in this module, you need to draw a force diagram for everyone. On the test, you'll need to draw a force diagram. Elizabeth, you need to head that way. Mom's filming. Please go that way. I'm going to point the camera at you right now. I need you to go that way.
I know, I'm trying to get food and not water.
All right, so a force diagram would look something like this. I always draw the thing that's supposed to be moving as just a box. It's easy. I can't draw people or wagons or whatever, so it's a box. So I would draw the force, say if something's pushing from this side on the box, I still would draw it that way. You can draw however you like. That's so unbelievably rude. This is really not okay. The frictional force, of course, will oppose it. So I have, the force that's pushing it. I have friction, which is always going to be a lowercase f. And of course, I have the weight of the thing that goes down. And if it's, being supported by a floor or something, of course, that floor is pushing back up against it. And we'll talk about that here in a minute. But you always need to do an a force diagram for every problem, especially on the test where you would like to get points for that, right? Okay, so when you draw that force diagram and you show a force going downward, the object's mass, which would be probably in kilograms or grams or something, times acceleration. In this case, acceleration is due to gravity. So mass times gravity would be the downward component of the weight of this thing. And then there's always an equal and opposite force that the floor supports it, unless it happens to be falling, for example. And I get to tell you about that, so I don't have to keep hedging around it. All right, so normal force. This upward force, F sub n, normal force, is a force that's perpendicular to a surface. So say my surface, like the floor is right here, normal force will be perpendicular to that surface of contact, and it opposes gravity. So if the surface, that's so rude to my students when you move it. This is hard stuff. Here, let's see. We're at 10 minutes, so I'm going to stop it, deal with the child, and be back with you in a minute.